Welcome back to the next video in our series. This will be a pretty quick one. We're going to go through two example problems of very common kinds of special triangle relationships you're going to see when solving triangle congruence postulate problems. Okay, so the first thing we look at here is every single time I'm told determine whether the given triangles are congruent, I'm going to start immediately thinking of what are my four postulates, and I'm going to assemble my toolbox, right? My four postulates being side, angle, side, 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 angle, side, angle, and angle, angle, side, right? Remember, the other two, angle, 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 and side, side, angle, are not postulates. We don't get to use those. So with these four, I'm going to look at the information I've been given and see which of these are most likely for me to pursue, right? I've only been given two pairs of corresponding and congruent sides here. But even that is enough to give me a good direction. Any of the ones that requires two angles and one side, these two, probably not going to use those, right? I'm probably going to stick to the ones that require two sides and then one more thing. So the question now becomes, what is the one more thing I can find? Well, remember when we do these, right? It's very, we don't have a lot of side relationships we get to use. Angle relationships is what we've been focusing on. So I probably can't do much to show that AB is congruent to ED, right? That's not really a thing I get to prove here. I'm probably going to be looking for the angle between the two sides, right? I'm not doing, ASS or anything because that's not a thing, right? I need to be finding if this angle is congruent to this angle. Is there some relationship we've learned before, some way we can prove that those two angles are congruent? Because if they are, we can use side angle side. Maybe take a second, go back in your notes, look for that, and pause the video, see if you can find it. And when you come back, hopefully you found it. All right. Hopefully you looked through your notes at your angle relationships and saw, is there a way to show that these two angles are congruent? Maybe you thought, I could do a double linear pair. Or maybe you remembered if I do a double linear pair, that's actually the same thing as a vertical angle relationship, right? These two angles are across from each other on an intersection that makes like an X shape, you see? That makes them vertical angles. And as vertical angles, they are guaranteed to be congruent. So now I have a relationship of two angles that are congruent between two pairs of sides that are congruent. Side, angle, side, right? I very specifically go in this order instead of ASS or SSA because I need to go the shortest way around the triangle to connect my 3 points. This way would be really long, right? And it would skip all this other stuff over here. It would skip these two angles. It would skip this side. I don't get to skip things like that. I don't get to go the long way. I need to go the shortest way around, S to A to S, right? And there we have it. That's all you need to do. Once you've proven side, angle, side, you're good. So the takeaway for this problem is that we have a vertical angle relationship, right? Anytime you see two triangles touching corners like this, where their corners line up to make two lines and an intersection, that is a vertical angle relationship. You are going to want to remember that. Every time you see this pattern, that is a vertical angle. It might not be used in solving the problem. It might not be helpful, but just knowing that that's a vertical angle will help you. It'll give you a little more information to work with. In this case, just enough information that we could solve it. The next relationship you're going to want to remember is something like this. Once again, I'm going to start by figuring out what postulates I'm likely to use. So I'm going to lay them out. Side angle side and side 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 both require two sides at least, right? I don't have any sides given to me here off the bat. So even if I could find a side, right, that's still going to be one more I need to find after that. It's unlikely. I'm probably going to be using angle side angle and angle angle side, right? Because I'm given two angles here, two pairs of corresponding and congruent angles. You see that? So these are the most likely ones. For both of these, I need to find one more side, right? So the question is, what side can I show that is shared by the two triangles, right? That is corresponding and congruent. If I was to separate these two triangles, it might be a little easier to see, right? So let's try that. If I was to separate this, I'm going to make a triangle on the top and a triangle on the bottom, okay? And what you might notice now is after I've separated the two triangles, these are two different triangles, but one of their sides, I would have to kind of pick like, okay, which side, which triangle gets the side? They both get it, right? That side in the middle is a shared side. One of the things that we talked about in the past that seemed a little silly was that things are equal to themselves or things are congruent to themselves, right? The reflexive property. It seemed stupid, but now we can see why it's handy. That side in the middle is congruent to itself. So if both triangles are using that side in the middle that's congruent to itself, then we have a congruent side, right? That side in the middle is congruent to itself. That gives us an angle, and a side. Angle, angle, side, right? Likewise here I see angle, angle, right? Going around. Angle, angle, side. Simple as that, right? So the second you see two triangles that are sharing a side, they've scooted up next to each other to make that kind of like diamondy shape, right? That is a triangle congruence relationship that allows you to have the shared side be one of your pieces of information. You have been given that the sides are congruent because it's the same side, right? That's very handy. So again, you're going to want to remember this, right? Shared sides is the second very common pattern you're going to see in these triangle congruence postulate problems. So be looking for those diamonds and be looking for those like triangles touching at the tips, that hourglassy kind of shape. Okay? Hopefully those examples help you see the process that we use to solve triangle congruence postulate problems, where we start by laying out the four postulates we can use, get the information provided to us by the figure, see which of those postulates we're likely to be using for the problem, and then see what other information we can possibly get out of the figure, either with vertical angles or shared sides or any other relationships we can use. One of the example problems we did in class talked about bisectors, right? To be able to show that two sides were congruent because they were bisected. So that's another kind of thing. You're going to use a lot of the information we've learned in the past about congruence to be able to find these corresponding and congruent pairs. Okay. In the next video, we're going to work a little backwards. We're going to start with congruence and see how we can use that to find parts that are congruent. So I look forward to seeing you then.